Okay, come to this question. Figure shows two blocks A and B, each having mass 320 gram, connected by a light string passing over a smooth light pulley. Okay, so this is the smooth light pulley, and there is a light string, and these two masses are connected. The horizontal surface on which block A can slide is smooth. This surface is smooth, no friction. The block A is attached to a spring of a spring constant 40 Newton per meter. So spring constant of the spring is given, whose other end is fixed to a support 40 centimeter above the horizontal surface. So this height is given 40 centimeter. So I am writing this surface is smooth. Okay. This surface is smooth. This height is 40 centimeter. Spring constant is 40 Newton per meter. Okay. And then masses are given. Both masses are 320 gram or 0.32 kg. Both masses. This is also MA is also 0.32 kg. Okay, so these things are given. And then it says that initially the spring is vertical and unstretched. So initially the spring is unstretched. So this is the height 40 centimeter is natural length of a spring. Initially, if it is unstretched, vertical and unstretched, means this 40 centimeter is the natural length. When the system is released to move, find the velocity of the block A at the instance it breaks off the surface below it. Okay, so breaks off the surface below it. So what does it mean? So what will happen as the point B is coming down, the object mass B is coming down, the mass A will go rightward. And after some time, what will happen? The situation will be like this. The spring will get stretched. Okay, and the block A will be somewhere here. Okay, block A will be somewhere here. And it says that it will get lifted. So lifted means what? Lifted means the spring force, the kx which acts here, that must be able to lift this object. So that must be able to balance the weight mg. So normal should not be acting at this point. So lifting on object is what? The object is lifted from the surface means the normal force is 0 now. Okay, so that thing we have to see. So we have to see at what point this can occur. So suppose the spring started from here and it goes at theta. So suppose let we assume the lifting occurs at angle theta. Lifting of A occurs at theta. Okay. So if it occurs at theta, so what will be the forces at that point? So that one force will be the kx, then one force will be the downward mg. Okay, and one force will be the tension. No normal. Here there will be no normal at this position. So if this is theta, we can write the kx cos theta must be greater than. So for equality, for solving purpose, we can write it equal to kx must theta must be at least equal to mg. Okay, for lifting. For lifting, this is the criteria. Okay, so this is one thing. Now, what will be x? So how do you find x? So for finding x, see, length is, suppose this length we call as L. Suppose length we call as L. So the extended length, how much will be this length? The extended length L dash, if we say the elongated length, will it be L sec theta? Okay. So initially the length was L. Now after it has moved by theta, the elongation is L sec theta. So elongation is now L sec theta. Not elongation. This is the extended length. So elongation will be equal to, the x will be equal to L dash minus L. And L dash is L sec theta minus L, where L is the natural length, 40 centimeter. Okay, so this is x. Now if you put it here at place of x we can write k L sec theta minus 1 cos theta equal to mg. So this much we can write. So if you solve it further, all the value k and all the things are given. So that is, if you put all the values, 40 Newton per meter, L is 40 sec theta. So cos theta, if you multiply, so cos theta sec theta 1 minus cos theta, this much we are going to get. And mg, so mass is 320 grams, so 0.32 kg. So 0.32 into g is 10. Okay, so if you solve it, 1 minus cos theta is equal to 3.2 divided by, so 40 centimeter, na 40 centimeter, that we need to convert into meter because we are writing everything in SI unit. So we will write it as this many meters. So 40 centimeters means 40 by 100 meter. So these things we have to consider. So 3.2, then 40 by 0.4. So 8. So 8 by 40. So 1 by 5. So cos theta we are getting as 1 minus 1 by 5. So that is 4 by 5. Okay. So cos theta is 4 by 5. So how much is theta? Cos theta is 4 by 5 means theta is 37 degree. So at 37 degree object will be lifted. So we have found at 37 degree object will be lifted. Now what is the next part we have to do? We have to find the velocity. So for velocity, we can use the conservation of energy because there is no loss of energy anywhere. So what are the different forces which are acting actually? While it is moving, there is a normal also acting. So normal, then weight, then spring force and tension. Okay. So here, if you consider what are the different forces. So if you write delta K plus delta U spring, delta U gravitation equal to work external. Okay. So this thing we can write. Work external is having two parts. We can have two parts, that is friction is 0, there is no friction, and normal will also be 0. Why? Because the displacement is perpendicular to normal. Normal is like this and displacement is horizontal, normal is vertical. So the work done by normal will also be 0. Both are 0. And change of kinetic energy. So change of kinetic energy we can write. Finally, suppose velocity is v. So v is the final velocity. Let v is velocity at the point of lifting. Let v is velocity at point of lifting. Okay. So final velocity is half mv square. Initial is 0 because initially starting from rest. Spring potential energy. So how much is spring potential energy? Finally, it is half kx square. And initially it was 0 because initially spring was relaxed. Then gravitational potential energy. So how much height it has descended? So h. We need this h. So we also need to find h. So how do you find h? So this h, will it be equal to this value? Will it be equal to h? From here to here, the object has traveled a distance h here. So the same value, the b will decline. So h will be equal to L sine theta. No, sorry, not L sine theta, sorry. L tan theta. See, this length is L and this length is H. So L tan theta will be H. Okay, so this much we can write. Or L tan theta, so we will put these things. So mg H equal to 0. So we will write half m v square plus half k. At place of x we are going to write this thing, L sec theta minus L. So that will be L sec theta minus 1, okay, square, this much. Then we have mg and h is how much? L tan theta. We have to write minus because it is going down. So minus mgl tan theta. So this is the equation. So I am explaining it again. The delta K is change of kinetic energy. The initial velocity was 0. Here the velocity was 0, and at the point of lifting the velocity is V, that we have written. So half mv square minus 0. Then change of spring potential energy. Initially the spring was relaxed, so 0 energy, and finally its expansion is x, and that x is calculated here. So this thing we have used L into sec theta minus 1. Then the gravitational potential energy, the object is coming down by height h, so minus mgh, and h we have written here L tan theta. This is L, and this will be L tan theta in terms of theta. Okay, so this is the equation. So now we have to solve it. So if you put all the values, it will be 0.32 divided by 2 v square. Then k is 40 divided by 2. L is 0.4 meter, so 0.4 square. Okay, then how much is sec theta? So theta we have calculated 37. Theta is 37, so sec theta will be 5 by 4. 37 is what? 37 is like this. This is 4, this is 5. So sec theta is 5 by 4. So sec theta is 5 by 4 minus 1. Then mgl, so 0.32 into g is 10. L is what? 40 centimeters, so 0.4. And tan theta, so tan 37. So tan 37 is how much? 3 by 4. 3 by 4. So this thing we have to solve. So we have put the numerical values, and we can solve it further now. So 0.16 v square, and then we have 20 into 0.4 into 0.4 into how much will be this one? So that is 5 by 4 minus 1, so it will be 1 by 4 square. So 1 by 4 into 4. Then if we solve this one, we are going to get 10 here. So 10 cancelled. So we are getting 3 into 0.32, so 0.96 equal to 0. So this much we are getting. So one more step we will solve. So this is 10, this is 10, and if this is also 2, so 0.16 v square plus 2 by 10 means 0.2, and then 0.96 equal to 0. Or we can write 0.16 v square equal to 0.96 minus 0.2. Okay, or we can write, so if we subtract this, how much we are going to get? We will get 0.76 by 16. So v square is 0.76 by 0.16. Okay, so this will be 76 by 16, and if you solve it further, it is going to be, if you divide it by 2, divided by 4. So first it is 8, then it is 38. Okay, 38. Then again it will be 4, and it will be 19. So 19 by 15, 19 by 4. Okay, so v will be how much? V is under root 19 by 2. Okay, so this much we are getting. So value of g was 10. Okay, so this much we are getting. So this will be the velocity. So this much meter per second.